Hello and welcome to the video. In this video we're going to be taking our first look at this new model from Hobby King here. Now this is the Raven 990. It's a discus launch glider or a DLG. Now it's just under a metre in length, which I'm guessing is what the 990 stands for, and it's the latest in a series of DLGs that Hobby King have done. But it is our first ever discus launch glider. We've never had one of these before. But the reason that I've got my hands on one of these to have a crack at is that it's something I've been interested in since last summer. I've talked to people like Dylan Graves, who is one of the world champions, and for me, I like those kind of planes that soar and glide really well anyway. Things like the Tundra, but specifically things like the Skywalkers, the Bixlers and the Night Walruses are fantastic. You can get them up to altitude, you can then shut the motor off and you can soar about. And you can catch uprising air and have a wonderful time. It's very relaxing, it's very cathartic. But I've decided to take a plunge and get my first DLG. So in this first look video, as I'm learning to fly the DLG, there's no point in me doing loads and loads of bits and pieces about how to set this up and how to optimize it. It's more a look at how it comes in the box, how you put it together, which is very straightforward. But I'm going to spend a little bit of time talking about the power system and how you put that bit together. But asking my Patreons about DLGs, it's quite common that a lot of us pilots are interested in the DLG and into getting into that side of the hobby, but it's a little bit of an art form. And I want to demystify and go through some of the stuff that I've been through over the past 2 or 3 weeks that we've been playing with this to get it all working. So first of all, let's talk about how you put this beautiful little thing together. And I do say it is beautiful because it is only 166 grams with all the electronics inside. So it's very lightweight, but it's very sturdy. The wings are transparent, it's this beautiful red colour, and you can see the spars and the internal structure of the wing through the transparent covering. But in the sunshine, it looks absolutely fantastic. It's a very quick and easy process to put it together once you've got it out of the box. The main body is already in one piece. All you have to do is attach the horizontal tail. The horizontal tail is held on by 2 screws. A firm nip will get them into position. The main wing is all one piece and that goes on to the top of the chassis. There's 2 servos underneath, one for each of the ailerons, and those cables from the servos go into the top of the little bubble canopy at the front where we're going to put our receiver in a second, and then the main wing is held on top of a couple of risers with this carbon plate, and again a couple of screws here. I think they're actually nylon that's keeping everything in place. Once you've got those 4 screws nipped up, last thing to do then is attach the elevator. The elevator is held naturally in a down position, so you need the servo to pull it upwards. And it's all done with one very fine cable. One end has a loop on it that you put into this little hook, and at the other end then you feed it through a hole in the servo that's there already, and then use one of the crimps that comes in the kit. Just need a pair of snipe nose pliers, crimp that down with a little bit of super glue in it, and that should keep it all set. Once you've got that done, then in the canopy there's lots of space, but you have 3 servo connectors. You have 1 servo connector for the elevator at the back, and then you have 2 servo connectors for each of the other controls, the ailerons in the wing. There is no rudder on this model, but I quite like the yank and bank style of flying anyway. The more expensive style these gliders do tend to have rudders too. Now the challenge comes, and this is the bit where I start to get a little bit stuck, is how do you power this thing? I'm used to whacking 1800 or 1300 or even 5000 milliamp hour batteries with big ESCs, battery eliminator circuits, loads of stuff in here. But the challenge with a discus launch glider is you want to keep it as light as possible. Now out of the box, the entire all-up weight of this thing was about 146 grams without any electronics in, and it reckons that the weight you're kind of aiming for is about 160. However, I found that we needed 20 grams in the nose to get it to balance perfectly at the centre of gravity indicated in the manual. And the way I found that out was I just opened the canopy and then started popping in loose change in a neat little pile in the middle of the space in the canopy until it balanced perfectly. Then remove that loose change, pop that on a set of scales, and found out that it needed 20 grams in the middle of this wonderful little beautiful smoked plastic canopy for everything to balance. Now, because that's 20 grams, I then thought, okay, now I need 15 grams for a battery, because I'm going to need about 5 grams for things like the receiver, potentially a battery eliminator circuit, potentially the extra bit of wiring to connect the battery to the BEC or the receiver, and all of that is probably going to be about another 5 grams by the time I've finished. So I went looking for a battery that was about 15 grams in weight. Now, Hobby King do their own battery for DLGs. The Hobby King Smart 5 volt BEC LiPo 250 milliamp hour, one piece, and that's actually what I would have loved to have get my hands on. Unfortunately, it's been out of stock the entire time, so I've had to figure out how to power this little guy, and that's where I want to spend the next 5 minutes just talking about that. And again, for those of you that are DLG pilots that have been flying DLG for ages, you might as well skip this entire bit. But for those of you pilots out there who are like me and are new to DLG, this was something I had to figure out that I didn't find documented anywhere. So I'm kind of presenting this for those of you that are interested in this model or one of the other DLGs out there, so you know what your options are. First thing you can do is actually power everything from a 1S LiPo battery. If you can find a 1S LiPo battery that's the right weight, and again we were shooting for about 15 grams, then it will probably power everything okay. I remember the time when anything below about 4.2 volts on a receiver would cause it to brown out and reboot, and you'd have all kinds of horrendous problems. Looking at the modern generation of receivers from FR Sky and from things like the orange stuff on Hobby King, the minimum voltages are at a level where you could run it from a 1S LiPo and get away with it. And also the servos in the model itself are probably going to be happy in the normal voltage range that you're going to get from a 1S LiPo. And that's typically going to be around 3.6, 3.7 volts up to about 4.2 volts. And if your receiver and servos are going to be happy with that voltage range, then you can get away with it. Now for me, I quite like the idea of all my electronics having a nice, healthy 5 volt supply. So I'm probably showing a little bit of naivety here, but I really want everything in the model to be running at a nice solid 5 volts, so the receiver is going to be happy and the servos are going to have a decent set of torque on them as well to control the surfaces as I fly around. Now in those instances, there are little devices from people like Maytech and others that you can put in here, and Maytech actually do one that is thumbnail size that you can put in line with the battery, and it steps the voltage up to 5 volts. Typically the output amperage on these little things is about 1.5 amps, which is more than enough to run a receiver and 3 or 4 of these little micro servos that you tend to get in the DLGs. So that's the second way I considered doing it. Was getting a 1S LiPo battery of about 15 grams and then using one of these little 5 volt step up things that would go into the receiver and then would also power the servos as well, to give me confidence that I'm never going to brown out my receiver. I'm going to have to work hard, and I'm not going to sacrifice any torque by running the servos at a lower voltage. However, when I went to try and find a battery that would fit in the canopy and would also weigh about 15 grams, the only one that I could find around here at the moment was a nice 2S unit. This is the little 200 milliamp hour pack that I found. It was very good. I kind of rummaged through all the pieces that I had here, and this is the battery that was around. So I thought, okay, I'm going to use this, and I'm going to use it with a little 5 volt BEC. Again, it's this little Maytech unit. We've used this in lots of other things as well, actually. We used it in the little 160 quad that we built with a KISS flight controller a couple of weeks ago. I tend to use them in all kinds of things where I want a really steady, solid 5 volt supply, but don't need ridiculous amounts of current. But even this will supply 1.5 amps. So this is the way that I've done it. So I've put the 2S LiPo battery connected into the UBEC, supplying 5 volts. That 5 volts then plugs into the receiver and also then powers all the servos as well. And so far, with the limited flying that I'm doing here, it works beautifully. It also means that I've been able to put the 2S battery slightly more forward than I originally thought, about another 8-9 millimeters towards the nose, and the center of gravity is absolutely spot on. I could have used a lighter battery in here and then added lead weight into the nose to get it to balance, but personally I would like all of the weight that I need to get the center of gravity where I want it in the DLG to be useful to me, rather than just dead weight, just essentially a chunk of lead. So hopefully that's interesting for those of you that have not played with DLGs before. I am starting to get the hang of this, and I'm looking forward to these long, calm summer evenings where I can go to the field and throw this thing up into the air and soar around without any motor at all. Thank you for taking the time to watch that video. We try and release at least 2 videos a week, usually a quick tip on a Tuesday and a more in-depth video on a Friday, and sometimes we manage to get a few more out as well. If you're interested in radio control, then the playlists are useful to have a look at. Anything that's called Introduction To is an organised set of videos that teach you from first principles about the subject that you're interested in. But we also have information about the majority of popular open source flight controllers, how to build quadcopters, fixed wing models, reviews, setups, unboxing, all kinds of things in here as well. So if you haven't already had a look at the playlist, then I'd recommend going have a look through here to see if there's anything that takes your fancy. Finally, we do also provide updates through things like Twitter, Instagram, and also post all of our 3D designs on Thingiverse as well. So if you like what we're doing here on YouTube, have a look at those things and subscribe to us there, and you'll find out what we're up to in advance of the videos coming out here on the channel.